Hello students. We were doing permutations. Let's solve some more problems. Find a value of n such that it is given that np5 equal to 42. Okay, np3, and here n is greater than 4. Okay, so we have to solve this. So both sides we can write here using the formula n factorial upon n minus 5 factorial 42 into n factorial upon n minus 3 factorial, right, using permutation formula. Then we can expand this, that is n into n minus 1, okay. N to n minus 1, n minus 2, n minus 3, n minus 4, and last you can write n minus 5 factorial upon n minus 5 factorial, right? This and this you can cancel. Same way on the other side, it will be 42 into n minus 1, n minus 2, and n minus 3 factorial. So n minus 3 factorial in the denominator and in the numerator gets cancelled. Now here n minus 1 is there, here also n minus 1, so we can cancel this. Also n you can cancel, okay, n minus 2. Okay. So the remaining thing is n minus 3 into n minus 4 equal to 42. Okay, so we have to multiply this. So it will be n square minus 3n minus 4n plus 12 equal to 42. So we will get a quadratic equation. N square minus 7n plus 42 minus 42 plus 12 minus 42. So it will be minus 30. Okay. So factorization, minus 30 and minus 7. So 10 3s are minus 10. So okay. So n is equal to 10 and n is equal to minus 3. So n, since factorial we use only positive values, so this we have to discard. So n is equal to 10. Okay. Second question, np4 upon n minus 1 p4 is equal to 5 by 3. Okay. Same way you have to solve. So I can take this here. Okay. So I'll write this as n factorial upon n minus 4 factorial 5 by 3 into n minus 1 factorial upon n minus 1 minus 4 factorial. Okay, so minus 1 minus 4, it will be minus 5. So this will be what? N into n minus 1, n minus 2, n minus 3, n minus 4, n minus 4 factorial. Okay, so this gets cancelled. Then the other side, if you expand this, this will be what? N minus 1 into n minus 1 minus 1. So that is n minus 2, right? 3, 4, n minus 5 factorial. So n minus 5 factorial and this gets cancelled. Then you can cancel this, n minus 1, n minus 2, minus 3. So n remains here, and here it is 5 by 3 into n minus 4. Okay, 3 you can take here, 5 you can multiply 5n minus 20, 5n you can take here, so this will be 3n minus 5n equal to minus 20. So this is minus 2n equal to minus 20. So n is equal to 20 upon 2, which is 10. Okay. Next question. You have to find r. This equation is given. Okay. So solving it, 4 factorial upon 4 minus r factorial, 6 into 5 factorial upon 5 minus r is 1 factorial. Okay. So this is 4 minus r factorial. So this will be what? 5 minus r plus 1. So 5 plus 1 is 6. So it will be 6 minus r factorial. Okay. We can expand this. This will be what? Can keep this as it is. Minus 1. Yeah. This will be what? 5 into 4 factorial. This you can cancel with this 4 factorial, right? This we can write 6 minus r into 6 minus r minus 1. That is 6 minus 1 is 5. So I can write here 5. Okay. Then 6 minus r minus 2. So it will be 4 minus r factorial. So this you can cancel with this. This you can cancel with this. So these things remain. Okay. 5 also you can cancel. So this thing I'll take this side. So this will be 6 minus r into 6. 5 minus r equal to 6. Okay. So you'll get a quadratic equation here. 30 minus 5r minus 6r plus r square. Okay. Minus 11r. 30 minus 6. 24. Okay. So 24, 11, 8 and 3. Minus 8 minus 3. Okay. R minus 8, R minus 3. So R is equal to 8 and R is equal to 3. Okay, so two values are there. Next example. In this, find the number of different 8-letter arrangements that can be made from the letters of the word daughter. Okay. So here they have given two conditions. First, vowels occur together. And in another, it is vowels do not occur together. Okay. Now here they have not given that we can use the repeated letters or not. Okay. So repetition is allowed. Whenever repetition is allowed, total number of permutation will be what? The given number of letters. Okay, 8 letters are there, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8p8. That is 8 factorial. right? Now using this condition, that is vowels occur together. How many vowels are there? A, U and E. 3 vowels are there. Okay, so we are taking these vowels together and this is one letter. Remaining letters are 1, 2, 3, 4, 5. 5 letters are there. So total number of letters will be what? 6 letters. Okay, so the arrangement permutation will be what? 6p 6, that is 6 factorial. Okay, now we have to count for this also. These are 3 letters, right? So the permutation of these letters will be what? Means first you are arranging this combination. Okay, this that is not combination, permutation of this letters, 6 letters, and then you are arranging these letters, that is vowels inside, a u e or a e u, like that. Okay, so this event is followed by this event. So here we are making use of multiplication principle, that is 6 factorial. Then the permutation of this will be 3p3, that is 3 factorial. So total will be what? 6 factorial into 3 factorial. Okay, that is 4320 when vowels occur together. Now we'll find out when vowels do not occur together. Okay, do not. Okay, so now you have to take all the letters. Total number of letters is 8. So 8p8, 8 factorial. Okay, but we have to remove when all vowels are occur together. So that is our 6 factorial into 3 factorial, that we have to remove. So this is like this it is. Okay, next question. In how many ways can 4 red, 3 yellow and 2 green disc are 4 are of the first kind, 3 are of the second kind and 2 are of the third kind? Okay, so here you have to first find out the total number. So this is 4 plus 3 plus 2, which is 9. Okay, now you have to take each one, 4, 3 and 2. This is when we use letters, same letters. Okay, when you have 3 E's, 2 I's in a letter and total letters are 9, then we take 9 factorial upon 3 factorial into 2 factorial, like that it is. So the permutation is 9 factorial upon 4 factorial into 3 factorial into 2 factorial. Okay, next question is the word is independence. Dense. Okay, find the number of arrangements of the letters of the word independence. In how many ways of the arrangements do the words start with P? Okay, so first you have to find the total number of arrangements. Okay, that is total number is 1 2 3 4 5 6 7 8 9 10 11 12. 12 factorial. Now we have to see for the repeated letters. I is only once, N 2 3, then D 2 times, E 1 2 3 4. Okay, so this comes to something 1663200. It is already solved in the textbook. Okay, this is your total number of arrangements of this word. Okay, letters in this word. Now first one, do the word start with P? So we are fixing P in the first place. Okay, now we have how many choices? Total are 12. One is fixed, so 11. So 11 factorial upon same thing, 3 factorial, 2 factorial, 4 factorial. Okay, so it comes to something 138600. Now do all the vowels always occur together. Okay, so we have to write all the vowels together. So D is 2 times, no, not D, vowels, A, E, I, O, U, E, 2, 3, 4, and I. Okay, these are 5. So 12 minus 5, 7. 7 choices we have, and this one we are treating as one letter. So total will be 8 letters, right? So 8 factorial upon, now the letters which are repeated we have to see, other than this, D 2 times, and N 1, 2, 3. Okay, and we have to take this permutation. Okay, so how many letters are there? 5. This is multiplication principle again, the same thing we did for daughter, vowels occur together, right? So 5 factorial, and E is repeated 4 times, so 4 factorial. Okay, then second is do the vowels never occur together. So here you have to take all. Okay, that is 12 factorial, that is the total number of arrangements we have found in the first, that is 12 factorial, 3 factorial, 4 factorial, 2 factorial, and then we have to remove vowels occur together. Okay, then do the words begin with I and end with P. So here you have to fix I, P, yeah, I in the first place, and in the last place it is P. So in between there are 12 letters. We are fixing I and P, so there will be 10 letters in between. So we have 10 choices. And how many are repeated now? P is not repeated, I is also not repeated, N is repeated 3 times, D is repeated 2 times, E is repeated 4 times. This is the required number of arrangement. Okay.